Today we'll be solving another simultaneous equation. This time around we have 2x plus 5y is equals to 11 and x minus 7y is equals to minus 4. We have another simultaneous equation and we'll be using the matrices method to solve this equation. It's a linear simultaneous equation. We have x and y, two variables, and also two equations. So we have equation 1, and we also have equation 2. Remember the plural for matrix, M-A-T-R-I-X, is matrices. So let's see the various methods we can use to solve simultaneous equations. We have the elimination method, we have using matrices, we have substitution method, we have the graphical approach, and then we have others. In our last two videos, we were able to solve the elimination method, and then also we are using this opportunity to solve another matrix method. So what's a matrix? A matrix is an array of numbers. This array of numbers is usually in rows and columns. So it could also be an array of numbers or also other mathematical objects arranged in rows and columns. So we have the contents of these matrices. The contents of a matrix is generally called an entry or element. So they are called entries or elements. Now, this is how a matrix looks. So in this particular matrix, we have one row and then two columns. One row and then we have two columns. So this is the one by two matrix. 1 by 2 matrix because it has one row and two columns. You have various types of matrices. You have 1 by 2, 2 by 2, 3 by 2, and so on and so forth. So this is just an example of how a matrix looks. So we'll be looking at our equation 2x plus 5y is equals to 11 and x minus 7y is equals to minus 4. And then we're going to put it in a matrix form. We will extract the coefficients of x and also the coefficients of y, and then we'll put it in this particular matrix. So what's the coefficient of x? In equation 1 we have 2. The coefficient of y in equation 1 we have 5. And then what's the coefficient of x in equation 2? We have 1. And then the coefficient of y in equation 2 we have minus 7. So what is the coefficient? Coefficient is basically whatever is multiplying the particular variable, and we have variables x and y. So this is where we'll put our x and our y's, and then we equate them to what we have on the right hand side, which is the constant 11 and minus 4 for equations 1 and 2 respectively. So the first row multiplies the x and y in order to give us equation 1. So 2, which is the first number, multiplies the first x and gives us 2x in equation 1. And then 5 multiplies the y to give us 5y in equation 1. and 2x plus 5y gives us 11, which is the 11 on the right hand side, on the constant side, in equation 1. We move to the second row, which has 1 and minus 7. So we start with 1. 1 multiplies x to be x, and then minus 7 multiplies y. It gives us minus 7y, and that's what we have in equation 2. And x minus 7y is equals to minus 4, which is what we have on the right hand side, and also in the matrix on the right hand side at the bottom. So all we have simply done is to express equation 1 and 2 in a matrix form. So we can call the first matrix A, where we have the variables x and y, we can call it B. And then where we have the constants, 11 and minus 4, we can call it C. So A times B is what gives us C. If A times B gives us C, what we have is AB is equals to C. But we try to solve for x and y, and therefore we make B subject of the formula. And if we do that, we have B is equals to the inverse of A times C. B, which are our unknowns, x and y, is equals to the inverse of A times C. Now in matrices, the inverse of A is given by 1 over the determinant of A times the adjoint of A. Like we can see at the bottom right, the inverse of A is given as 1 over the determinant of A times the adjoint of A. So like we said earlier, we said that AB is equals to C. AB is equals to C. Therefore, B, which has what we know, will be equals to what? What's the guess? A inverse times C. A inverse times C. That is the inverse of A times C. And what is the inverse of A? Is equals to 1 over the determinant of A times the adjoint of A. What is the determinant of A? If you look above, you look at the matrix that has the coefficients 2, 5, 1, and minus 7. That is the matrix A. But what we want to do now is to find out what the determinant of A is. We want to find out what the determinant of A is. And that's simply 2 times minus 7, 2 times minus 7, minus 1 times 5. Our determinant of A is 2 times minus 7 minus 1 times 5. Now what do we have there? We have 2 times minus 7, we have minus 14 minus into 1 times 5, which is 5. So we have minus 14 minus 5. Minus 14 minus 5. We are owing 14, and then you owe another 5. That gives you a total of minus 19. That is a total of 19 being owed. So we have solved the determinant of A, and our answer is minus 19. So let's just put that aside. We'll use it in the nearest future. Now what about the adjoint of A? The adjoint of A, represented as ADJ A, is simply, let's go back and look at the matrix A on top left, where we have the 2, 5, and then the 1 and minus 7. In short, the coefficients of x and y in the simultaneous equation, the coefficients of x and y. That is, what are the values that have been multiplying x and y that form the equation 1 and 2. Now the ones 2 and minus 7 in that particular A, what we do is to exchange their positions. Where you see 2, put your minus 7, and then where you see minus 7, put 2. Then when you look at 1 and 5, they will maintain their position, but they will change their current value. Their current value is positive. When we find the adjoint, they will now become negative. So let's see how the adjoint looks. So that is the adjoint of A. Now going back and looking up top left where we have A, we have 2, 5, 1 and minus 7 on the top left. But like I said earlier, when we find the adjoint, all we simply do is exchange the 2 with the minus 7. So they will just swap positions, and then the 1 and 5 will retain their positions. However, they will change their signs. So we have plus 5 there, it now becomes minus 5, and then we have plus 1 there, it now becomes minus 1. So we have what it takes to find the inverse of A, which is 1 over the determinant of A times the adjoint of A. Our determinant is minus 19, and our adjoint is, as shown, the resultant matrix where we have minus 7, minus 5, minus 1, and 2. So let's just simply substitute the values of the determinant of A and the adjoint of A in order for us to find A raised to power minus 1, which is called A inverse, that is the inverse of A. So our determinant of A is minus 19, our adjoint of A is as shown, and therefore if we substitute it into the equation above, we're able to get the inverse of A, which is 1 over minus 19 times minus 7, minus 5, minus 1, 2 as the matrix. So we know that B is equals to A inverse times C. That is, B is equals the inverse of A times C. We have successfully solved for the inverse of A, which is at the bottom left. Now we will add C. Remember that C is the constant where we have 11 and minus 4 in the matrix. So we have 1 over minus 19 into the adjoint of A, which is minus 7, minus 5, minus 1, 2, and then we multiply it by C, and C is the adjoint, C is the matrix where we have 11 and minus 4. Now, we'll leave the 1 over minus 19 outside the bracket, and then we'll simplify the two matrices. So what we'll do is to expand and simplify the matrix. So we have minus 7 on top. Minus 7 will multiply 11, and then we'll add minus 5 times minus 4. So that gives us the value on top. Then we have minus 1 multiplying 11, and then we'll now have 2 times minus 4. And when we add that, that will give us the value at the bottom. So what we have at the top, we have minus 7 times 11, we have minus 77, plus we have minus 5 times minus 4, which gives us plus 20. So it's going to give us plus 20 by the time we open the bracket. And then if you look at the base, we have minus 1 times 11 is minus 11, plus then you have 2 times minus 4, which is minus 8. So when you open the bracket, the minus and the plus becomes minus. So you have minus 11 minus 8. So let's simplify this. We have b is equals to 1 over minus 19 into minus 77 plus 20. And then we have minus 11 minus 8. If we simplify what we have on top, minus 77 plus 20, we'll have minus 57. And then minus 11 minus 8, we have minus 19. So let's just do some quick calculations. We'll expand the b value, and what we'll do is simply multiply 1 over minus 19 by minus 57, and then we'll also multiply the 1 over minus 19 by minus 19. Let's see the quick calculation at the side. We have 1 over minus 19 times minus 57. The minus cancels the minus. 57 divided by 19 is 3. We'll also do the same for the base, which is minus 19. We'll multiply the 1 over minus 19 times the minus 19. And then the minus sign cancels the minus sign there. 19 divided by 19 is 1. So our simplification shows that b is equals to 3 over 1. And remember that our b is represented by our unknowns x and y. So therefore, our x is equals to 3 and our y is 1. Therefore, these are the solutions. But we want to do a quick check to be sure that we are correct. We'll use equation 1 to check. And our equation 1 is 2x plus 5y is equals to 11. So we'll substitute the value for x, which is 3, and y is 1. And we do anticipate that we'll be getting 11, but let's see whether that happens. So anywhere we see x, we put 3, and where we see y, we put 1. So 2 times 3 is 6, and then 5 times 1 is 5. 6 plus 5 is 11, and this satisfies equation 1. We'll do the same for equation 2 to be sure that what happened in equation 1 will also happen in equation 2. That is, the variables x and y which we have solved for should also satisfy equation 2. So what do we have in equation 2? We have x minus 7y is equals to minus 4. So let's see whether the resultant output based on what we are going to put there will give us minus 4. So what is our x? Our x is 3. And what is our y? Our y is 1. So we substitute those values in equation 2. So we have 3 minus 7 into 1. That gives us 3 minus 7, and 3 minus 7 is equals to minus 4. That is from the second equation, x minus 7y is equals to minus 4. So we have seen that 2x plus 5y is equals to 11, which is equation 1, and x minus 7y is equals to minus 4, which is equation 2, and that the values x is equals to 3 and y is equals to 2 satisfies both equations 1 and 2. So therefore the solutions for x and y above, that is x is equals to 3 and y is equals to 1, are correct because they satisfy both equations 1 and 2. Thank you.